All right, we're going to talk about today about breaking the PR review bottleneck. First of all, I'm Pavel. I am a lead AI engineer at Revity. It's a small boutique consultancy company. And I've been in IT for more than 18 years. I've been working in various different companies, small, large, enterprise, startups, and many teams, they're facing a very similar issue. Their delivery cycle is slow. And slow, not because they have code slow, no, because they're usually stuck in PR reviews. And we're going to talk about it today. However, before we do that, let's say thank you to our sponsors. Without them, it wouldn't be possible to have this conference and present here. They all have booths, so if you haven't seen them yet, please go and say hello. They're all lovely people. And most importantly, you might have your bingo card, so please get a stamp on your bingo card in order to win one of these amazing prizes. Well, that's enough about that. Let's move to our problem. First of all, I want to say and reiterate, speed isn't about writing code faster. It's about removing waiting. You can find it in many other situations. So, for instance, you can find it on a freeway, or you can find it in sports if you do. And let me give you a real example. So I was working with one of the large enterprise companies. Hundreds of developers, distributed team, multiple offices in different time zones. And one of the teams was frustrated with a very slow delivery process. They were in the project for about 1.5 years, and they're going to continue for another few years at least, I guess. They come to us and said, look, we have such a slow delivery, and we want to speed it up because it's not acceptable. And what if we introduce AI tools? We're going to write code faster. We're going to speed up our delivery. And we said, look, just hold your horses. Let us analyze first what is your problem, and maybe there is something else we can help you with. We started looking, and we found that they have a very slow pull request cycle. Some of the pull requests were sitting in a queue for more than 12 weeks. So 3 months. It's almost a dead code, and it's an enterprise company, so they value their money. They are not open source project where you're not sure when you get response, no. So we said to them, if you're going to introduce AI tools now, most likely you're going to explode your delivery queue. Most likely you're going to deliver even slower than now. Imagine, AI can generate 10 times more than you in one day. And imagine that you have 10 times more pull requests sitting without a review. Either you're going to suffer quality, or either you're going to slow down the delivery even further. And they listened to us. They started looking into the process. They adopted changes that we're going to discuss later. And as soon as they resolved their bottleneck, they introduced AI tools. And that actually was helpful. So you cannot really speed by pushing more through the bottleneck. There is a queue theory that suggests that if you are trying to speed up while you have some congestion, it won't help. You can find an example on a road, for instance, on a freeway. If there is a traffic jam, you cannot accelerate. It just won't be possible. You need to resolve the congestion first, and then you can move faster. Similar with software development. You need to remove the congestion first, and then you can move faster. And in order to understand where's the congestion, well, and in our case, we're talking about pull requests, we have 3 metrics that we measure. First of all is time to the first review. It's basically the time of a review time to turn around and come back to you. Not necessarily with a review, complete review, but maybe with a message. Hey, I've seen your pull request. I'll come back to you when I get free, maybe an hour, maybe tomorrow. But at least we know. We can set our expectations, and we can start working on something else. A Google research shows that if the time to first review is less than 1 hour, then the pull request can be merged within 24 hours quite likely. And this is important. So, because if we merge the pull request within 24 hours, it reduces our median time to merge. And this is exactly what we're trying to fix. So we want to reduce median time to merge and make it as small as possible. But we don't want to make it fast, just fast. We want to still keep our quality gates, because we don't want to deliver code that has bugs and issues and having angry customers that coming back to us and saying, you know, something doesn't work. For some companies, it's still acceptable. I totally understand. Some, let's say, startups, they might value a fast delivery over quality, but it's their choice and their risk as well. We still need some kind of quality gates, and we need to measure how good they are working. So now, as we know what we measure, let's talk about problems. And there are a few of them. Eight major problems that we're going to debunk. The first one is late debates. I guess everyone is familiar with that. Imagine that you implemented a feature, spent a few days writing the code, you wrote it, unit tests are passing, everything is fine, CI is working, and then you send a pull request, and somebody came back to you saying, why have you decided to use this algorithm instead of that? Why have you decided to use this approach? Why didn't you try that? And you know, this conversation might drag for quite a while. So you might have a long conversation in the pull request, just defending your solution or maybe finding the truth. Or maybe eventually you find out, yes, actually your solution is not optimal, and you come back, rewriting the code. It might be even worse. And the reason behind it, sometimes re-engineering, even harder than writing from the scratch. Well, okay, so you come back to your code, started rewriting it, and decided, why don't I include maybe a couple of more bug fixes, just to, you know, it's going to be faster. And now you're ending up with mega PR monster. I call it that. It's my favorite, and I've been guilty of having it, many of them. So imagine it's more than 2,000 lines of code, 30 files, 10 new dependencies, I don't know, you name it. And the problem with that, it's extremely difficult to review. First of all, it requires way more time. Secondly, a person who reviews it needs to load that context, understand it, understand maybe one problem, but anyway, understand the problem deeply before they start reviewing and writing comments. And lastly, if you see that's such a load, you might think, oh, I'm busy. I know it's going to take me 4 hours. So if I'm going to do it now, I won't complete my job. And they're pushing it back. And pushing and pushing and pushing, eventually you ended up with no reviews. So you decided to fix that and split it in multiple pull requests. And now you have a problem. You have a pull request number 1, pull request number 2, pull request number 3. They all depend sequentially on each other. First one is stuck. Now you cannot deliver any of those because the first one is stuck. And there might be multiple reasons for that. One of them could be, I call it review roulette. Essentially, you made a pull request, and now you're thinking who you should assign it to. Maybe to Alice, because she's a team manager. Maybe to Bob, because he's a lead architect and he knows how it's supposed to look. Or maybe to Carlos. He's been working on APIs in this project for the last 5 years, and he knows all the ins and outs, and he might be a right person for that. So you don't know. Nobody knows. Nobody acts. Eventually you decided, why don't I add the entire team? Great idea, isn't it? And now you have a responsibility diffusion problem. That's actually a psychological problem. So there is a fact. So if somebody needs help and ask a crowd to help, very likely nobody will come to them and offer the help, because everyone thinks there are so many people. Definitely someone will do that. If that person asks only one person, quite likely they will get it. Well, not quite likely, but the likelihood is much higher. Same with pull requests. If you assign it to the entire team, everyone will think, there are so many people, someone will definitely do that. Or they might just skim it. Looks good to me, but nobody will truly review that, because They're not responsible for that. So eventually, you ended up with one single person. You assign it to one person, I don't know, who? Carlos. And you're waiting for review and nothing happens. Why? Because there are multiple reasons. Carlos might get sick, he might get on leave, or he might be busy and just forgot to respond to you. And you wait for another day and nothing happens. It's really frustrating. Eventually, Carlos comes back to you with a pull request review, and there are 50 comments. 48 of them are trivial. You name this variable that. We need semicolons at the end of the line. Use four spaces instead of 2. Simple styling issues, and only 2 important. Only 2 about security and performance. You look at these pull request review and think, 48 comments. That's dreadful. To work on all of them, because you cannot close it until you completely resolve them. It's not pleasant. And while you're working on them, on these simple issues, you might miss these 2 important. The quality gate doesn't work. That's not what we don't want to see. Eventually, everything is fine. You finally got an approval. You're about to merge and about to press the button, but somebody pressed the button just in front of you, and now you have a merge conflict. So, what do? You check out your code, you check out the branch, rebase, fix, and go through the entire process again. Just about you press the button again, you got another merge conflict. You might cycle it several times until finally it's fixed. As you can see, it might take weeks before we can merge it. Some cases, as we've seen, 3 months, or even more. Well, you see that these problems are not human problems. These are system problems, and system problems require system solutions. Well, likely we have large open source projects that are facing these problems, but on a scale. If you think about large open source project, not a small one, but I'm talking about large, thousands of contributors, distributed across the globe, different time zones, and they're all working on their free will. They're not getting money from that. When they have time, they contribute. When they have time, they review. And still, somehow, these projects are working. Somehow, they're delivering. They're merging. So what they do, something that we can learn from them. Let's talk about it. Well, before you start coding, you can move the conversation from the solution to actually design phase. You can create a simple document, 2-3 pages, write something there, and maybe ask about, maybe propose a few different solutions, maybe ask a few questions, and start a conversation. You might find it much easier to actually write these documents and have a conversation in them, and cheaper to iterate over them rather than rewriting your code with a few pull request iterations. Who's using that? Well, there are multiple different formats. A couple of them quite popular, ADRs and RFCs. If you're familiar with them, ADR is Architecture Decision Request. RFC is a Request for Feature Comment. So for instance, Rust, 2,500 contributors across the globe. They're using RFCs every time when they change anything in language. And they are delivering quite regularly. And they don't have major issues with that. And the reason behind it, so they move their late debates to a design phase. Another solution could be a code owners. So you don't need to think about who needs to review your code. You have a file that basically maps a folder to a few people, and if you have a change in this folder, it's automatically going to assign to the right person. Let's say GitHub supports it natively. They have their they support code owners files, but there are other solutions. For instance, Kubernetes, they have owners files. It's very similar. I would say a little more complex, but overall it has a similar idea and similar purpose. They have more than 3,000 computers, and they don't have issues with assigning it to the right person. All right. What about automation? We know that robots are doing something well, right? let's let them make work that they do it well. For instance, merge queues. Instead of waiting for the pull request approval and pressing the button and resolving conflicts, you can automate it. You can use merge queues. Again, GitHub natively supported. And that will check the integration with the latest main. It will resolve simple conflicts. It doesn't need for you to press the button to merge it, so it helps to automate certain steps. Noticeable projects that are using it, for instance, again, Kubernetes, they have their own bot called Tide. Rust have their own bot called Bors. Well, it's just, it's something that other projects are using. To fix linting storms, nitpick storms, you can add auto-linting. So essentially, you agree with the team how it's going to look like, and then you can do auto-linting either on CI. Every time when you create a pull request, CI runs your build and also check if it actually aligns with the style requirements, style guides. You can also do it manually by running the same script locally on your machine, even before you submit pull request, or you can automate it even further. So you can create a pre-commit hook in your local Git, and whenever you about to submit or commit something, it actually runs the script and check your style. Does anybody use Go? Yeah, a couple of people, yeah? So you know Go format, right? So it's kind of, yeah, and exactly, they're pursuing the same goal. So they want to make sure that everything looks exactly the same. So you don't have conversations about it needs to be moved left, right, shifted, and so on. So it's controversial, not everybody likes it, but it works, right? Okay, human systems. Well, we're all human. We can forget things. We can get sick. We can push back because we're busy. For this, there is actual role called PR Wrangler, again at Kubernetes. So if they have SLA 24 hours, if within 24 hours somebody doesn't respond, then that person is going to actually talk to a responsible person and check if they're actually available and can review and try to move things. Not only Kubernetes use it. Node has something similar. They call it review team, if I'm not mistaken. Similar purpose, but multiple people, because well, they decided to use that way. If we're talking about large pull requests, so we can obviously make them smaller. It's easier to review, but also we can stack them. Well, let me talk through that. For instance, React, they all advocate, and Google, we already touched that. So they're advocating in small pull requests. So they suggest 400 lines should be the max. Well, again, every team is different. So someone will find that maybe not 400, maybe 500. Someone will find maybe 300 lines is optimal for them. But overall, smaller you have, faster you have, faster review you're going to have. Facebook, for instance, they also created a tool called Sapling. Essentially, it's a tool that helps to stack pull requests. And their idea is you spend a little more time in a design phase. You have a feature split on multiple deliverable chunks. And when you implemented the first chunk, you can start working on the second. And then you actually can work you can stack them and work independently from the first chunk. Well, I hope it's clear for you. Well, I can see it might not work for every team, and it very depends on other factors, but there is an option. This one, I guess it might be quite controversial. And, Agile, there are multiple different flavors. But fundamentally, Kanban doesn't really fix any problems. It helps to visualize them. It helps to visualize bottlenecks. And when you see the bottleneck, then you know that you need to fix it. If you don't see the problem, how do you know what to fix? Who's using them? Chromium. Chromium use it in, well, some teams, not everyone, but some teams of Chromium using it. And they do more than 1,000 commits a day. So obviously that's something that works. All right, now let's admit elephant in the room, AI. We're all using that, well, to some extent. And we can use AI to review our code. There are two options, I guess. The first option, to do it locally on your machine. Whenever you write the code, it doesn't matter if you do it with AI or do it manually, but you can ask AI to actually check if your solution is optimal, if it can find some mistakes, if it can help you to optimize it. Second, you can do a PR automated reviews. For instance, on GitHub, you can click the button and invite, I don't know, CloudBot or something similar to review your code, and it might find a few different issues that might be fixed before you actually ask someone to have a second look. Well, given that we talked about AI, we need to talk about AI-generated code as well. Who's using AI for writing code? Oh, wow. Yeah, quite a lot. So I guess you find that AI is extremely productive. It can write the same amount of code that you, and it takes it, I don't know, 5 minutes, that you might write in 1 day. And that's not it. It tends to over-engineer solution, right? It always creates these kind of factories and abstractions and, I don't know, tries to pull, try to reinvent APIs and dependencies and brings everything together, and then you look at that, why have you done this? More than that, it doesn't know much about your organization. It doesn't know about your code. It doesn't know about your styling. It doesn't know about microservices and services and third parties and data stores that you're using. There are options to overtake it, so you can include it in the context, but the context window is limited, so you cannot include everything. So it is impossible for AI at this stage to know how you work. It doesn't know the herd knowledge, that acceptable styles in the team, and the process. To some extent, it could, as we said, show the context, but it still requires some additional review. And also, who's responsible for reviewing the AI-generated code? Well, I guess you orchestrated it, you instructed, you prompted, so you're responsible. So before you submit the code review, well, before you submit AI-generated code to pull requests, so you need to do your own check. Well, first of all, how do you do that? I would say that you need to challenge it. Every time when AI generated your solution, challenge it. Is it the optimal solution? Have you tried this? Have you think about that? You might find that actually after a few iterations, you might get a much smaller, much better, much neater, much more elegant solution that was original. Or, well, it might turn out that you might have the same option. Second, verify. Sometimes AI might produce a code that looks extremely legit, perfect styling, unit tests, good documentation, everything looks perfect, but it doesn't solve your problem. Fundamentally, it's still there. You need to verify it. You can test it, you can write unit tests, you can go through code and check it, but fundamentally it needs to be done. Next, check for hallucinations. It might happen. Every now and then it happens. You see it will try to call an API that doesn't exist, or it will try to recreate an API that you already have. You just forget to mention about it. So you need to check for that. Sometimes it pulls the dependency of the version that it's not there. You know that. Or it will try to create a dependency or pull the dependency that you don't need. So you need to check that as well. Check for hallucinations, check for something that obvious and you can spot easily. Next, you need to write mandatory tests. It's non-negotiable, in my opinion. You might think differently, but I guess tests are going to be helpful. I reckon unit tests are sort of a standard for most of the companies. Many companies are also doing integration tests, UI tests, and so on and so forth. And you can do it as well. And you can do it with the help of AI. As we know, it's extremely productive, so it might write this test within minutes. But you still need to verify that these tests are actually legit, because I've seen sometimes AI creates a unit test that actually has a legit name, legit description, legit documentation, but has an assert that always true. You need to verify that. All right. As AI writes lots of code, ideally you need to split it, because if you load this all the generated code in one session, in one pull request, most likely it's going to be overwhelming for other developers. So I would recommend to split it. If it's 1,000 lines of code generated by AI, split it in 3, most likely. And last, watch for overcomplications. If it looks too complex for you, most likely it is. We know that AIs tend to do account for generic solutions and create abstractions and create factories and interfaces that are actually not needed. For you, 2 lines fix, you don't need all these things. All right. As we discuss these solutions, how can you implement them? What can you do? Well, I would suggest start with something simple. Auto-linting can be implemented within a day. If you have an agreement with the team, how the code should look like, great. You can implement it within a day locally. So just as an agreement within developers, execute linting every time when you finish development or during the development. Or you can create a CI script that actually runs it on CI. I would recommend to do it both. Sometimes you forget, sometimes it doesn't work, sometimes your style slightly diverged from the accepted style by the team. So if you have both gates, it's going to work better. Next is code owners. It's also quite simple. So essentially you just need to create a file that maps folders to developers. And as soon as you create a pull request, the CI is going to pick it up and going to assign to the right person. I would recommend not to add more than 2 developers to one folder, because you might get into the responsibility diffusion problem. It's still a good idea to have some redundancy, but overall it's probably not a good idea to have more than 2. Again, everyone is different. There is no silver bullet. Whatever works for your team. You might find that 5 developers working better for you than 1. And last one is Kanban flow. Again, I get it. Some people might think it's controversial. Some people tried it, it didn't work, but maybe you can give it another try. There are multiple different solutions that you can use. Jira has it, Trello has it, or if you like, you can actually use a physical board. For instance, I personally prefer physical board. It's like popping bubble wraps. When you move the card, it's just, instant satisfaction, just yes, yes, yes. So yeah, it doesn't take long to create a board, but it's a cultural shift, so it might take longer, maybe a week, maybe months, depends on the team, until people start getting value from that. But as soon as you start getting value from that, and as soon as everyone is agree, and you might go through a few iterations of Kanban board, adjusting VIP limits, adjusting columns, shrinking, expanding. So you might find something that works for you. So that's my recommendation for quick start. Again, everyone is different. There is no silver bullet. There are many ways to skin a cat, and something that works for one company might not work for another. Or presumably, your company might already using a few of those solutions. Anyway, I just want to reiterate that quality lives in the guardrails and speed lives in removing waiting. As we can see, if we think about development, it's not only about writing the code. Writing the code might be maybe 40% of your development time, and the rest is anything else. Meetings, agile ceremonies, pull request reviews, CI/CDs, or maybe troubleshooting or learning. So in every step, they have their own issues. And if you at least optimize one of those, and presumably pull request could be one of the best candidates for that, you might find much better much faster delivery cycle. So again, have a look, try what works for you, and hopefully you will get good results. That's it from me for today. Do you have any question?
There's a hand straight up at the front.
Thank you. That's a very nice talk. Just about RFCs. On open source repos, I observe RFCs which sit in there like, for example, if I have issue with open source project package I'm using, I'm going to it and I found, oh, someone reported this bug. So there is, it's open bug, it refers to, oh, we have RFC to solve this bug. I'm looking on RFC, okay, it's 1 month old. I probably will wait for it, it will be solved soon. Then it's another month, then it's another month. Then in one repo I experienced 2 years. So is it really solving problem and shifts it? Especially because this RFC has bunch of links to, oh, this is how I solved in my code sample, this is how I solved in my code sample. Is it in just shift the problem to RFC and not solving solution? Because when we build for enterprise, we actually need to deliver this in like less than 1 month, let's assume. Open source projects, they can afford holding these RFCs for ages because they try to deliver the best quality, not maybe the fastest outcome, and it's completely kind of different goals. So what do you think about it?
Yeah, it's a good question. Well, I guess there is no easy answer for that. First of all, we want to say that you can also have some kind of SLAs on RFCs. So if RFC is sitting in your organization for 3 days and nobody has responded to that, assume that it's a green light. Again, it needs to be in agreement with the team. Because without RFC, you probably would do it in a code that way anyway, right? So RFC is about to move the late debates to the design phase when it's cheaper to do, rather than just stopping through the iteration and through the delivery process. It's not about having RFCs just to have all these conversations. No, it's about to solve the problem of re-engineering your solution. Imagine that if that happens in open source project, because everyone has, well, most of the time, people are volunteers in open source projects. Not most of the time, but quite often. And imagine that they engineered solution, and then within a couple of days, someone comes back to them and say, look, this is not optimal, it doesn't solve my problem. Please rework. It's going to slow down delivery further. If RFC stays full, let's say 2 years, if they're going through the development process, at some point they might just forget about it. Enough. So, yeah. Also, RFCs might be quite beneficial for AI development because you have a conversation, it embeds the context, and when you ask AI to implement a solution for you, it knows that you already tried you discussed a few different options. Some of them are good, some of them are not, so it knows about it, and it will try, well, not necessarily, but quite likely it will choose the most optimal output.
Any other questions?
So I have a question. You mentioned the Copilot PR reviews. So my team has been using that. From our experience, it leaves a lot of comments, and every time you push a new commit, it'll just spin up another bunch of comments of files that are unrelated to what you just touched. So we've started updating the instructions, and I'm just wondering, do you have any recommendations on, I guess, how to best utilize the Copilot PR reviews, and how is it beneficial to have a lengthy instructions file that puts into detail how you, I guess, the repositories, patterns and stuff like that, or is it better to have it a little bit more, a bit shorter, a bit more specific? Do you have any recommendations at all?
Yeah, that's a good question, great question, and you're right. I guess you're on the right track. So to make the most out of the, let's say, Copilot GitHub review or something similar, so you need to have good instructions. So essentially it's instructions for agent, how to act and how to understand your repository. But it doesn't mean that GitHub Copilot or something else will give you the best output. It might be a first quality gate, and personally, I think that some of the comments could be ignored and just resolved by a developer. If it's not a problem, then everyone will agree with that. If it's a problem later on during the code review, someone might pick it up. Well, again, not necessarily, but quite likely. So I guess you probably just need to tune the instructions to suit your style most. That's my best advice. And again, it really depends on the model. So some tools are working slightly different, but yeah, you won't get as good results from tools like GitHub Copilot code review, because it doesn't know about your organization. It doesn't know about your full repository. It only sees the diffs of your pull request. It doesn't know anything about surrounding microservices and APIs and other tools that you're using. So it can only give the best as it could, and it tries. But yeah, you still need a second pull request review.
Hi.
Sorry.
So I've been using stack diffs recently at work, but I'm finding there's a lot of time put into actually composing each branch to be merged, and then when I do put them up, as soon as I rebase one of the branches into main, it closes the PR. Do you have any tricks on how to do that more efficiently?
Oh, sorry, I missed the question. Could you please repeat it?
Do you have any tricks about how to do stacked pull requests on GitHub any more efficiently?
Yeah, that's a good question. So stack pull requests are working when you have an efficient process. If you have an efficient process, you're still going to have a problem with pull request stack. I call it domino effect, because essentially you cannot manage the second pull request until the first is merged. So if you have an efficient process, it's going to speed up the pull request even further and development even further. But if you have a slow process, I don't think it's going to be helpful, unfortunately.
Right, thank you.
Yep.
Thanks, Pavel. Great talk, mate. What are your thoughts on the applicability of practices like trunk-based development and pairing, mobbing, and that in this day and age? Given that we used to try and get past this problem of PR bottlenecks by just removing PRs entirely, having two biological humans reviewing code, and now we've got sort of AI to pair with. Do you think that sort of changes the game a little bit? Are those practices still applicable?
I think so, yeah. And I guess it depends on the team and depends on the organization. So, for instance, if it's more, organization that requires more security and more quality, banking, for instance, so they might have more formal processes and it might go through very rigid pull request review, and the pair programming might not work, but for someone else, it might. So, and in my opinion, I actually quite like it, because pull request is not only about quality, it's also about sharing knowledge. So what's been done, how it's been done, why you've done this, have you tried a few different options, and explain it. And it could be upskilling as well. So if you're talking with, let's say, a more junior developer, so you can pass your practices, your experience to these people. So in this case, pair programming will be, or pair pull request review will be more efficient than just a pull request in GitHub, for instance.
Thank you.
Any other questions? Sorry, I'm being blind apparently.
Thanks, great talk. I think on the first slide you mentioned that if pull requests get reviewed within an hour, they generally get merged within 24 hours. And then later you said you had someone who would poke people after 4 hours if PR hadn't been reviewed. How do you balance that against the context switching needed for the reviewer?
Mm-hmm. Yeah, that's a good question. Well, I guess that's a complex question and a complex solution as well. And in my opinion, it's personally for me, it's much easier to review a smaller pull request. If it's a smaller pull request, I can find and allocate half an hour, maybe an hour to truly review, try, test, see if it works, write a comment, maybe try to find a better solution, come back to a developer with my thoughts. It's easier to do with a smaller pull request. If it's a massive pull request, most likely I won't have time for that. Most likely we'll just skim through that and, well, yeah, maybe there isn't a problem, maybe there is a problem. So I'm definitely advocating for smaller pull requests, so it's much easier to switch the context, because, you know, if you take a break for tea break, coffee break, lunch break, so after that, you already switched your context. You can go and try, go and do a pull request, for instance. If you use Kanban, for instance, Kanban advocates for pulling from, well, on you it's on the left, on the right, from the right to the left. So every time before you start a new work, you actually pull, see what's closer to delivery. If there is anything to test, well, again, depends on how the team's structured. But let's say pull request. So instead of starting a new job, new task, you pull from the pull request, review that, left comments, and then you can start your work.
Yeah, cool. Sounds good. Thanks.
Okay, we've got time for one more.
Thank you very much for the talk. Just wanted to follow up on the size of the pull requests. My team is currently struggling with reducing the PR sizes. While everybody understands ideologically that it's a good thing to have smaller PRs, but I found that it only works for us only when the tickets are predefined earlier in planning and they account for smaller PRs. But somehow when the tickets are just a bit more vague, the developers themselves struggle to break that down into smaller PRs. And I try to encourage the culture of a pull request is not like a unit of work, it's a unit of collaboration.
Yeah.
What would your recommendation be to developers? How to think about like how to make their PR smaller? What's some practical advice? Thank you.
Yeah, that's a great question. Again, everyone is different. Depends on the language. It's also some languages are more verbose, some languages are less verbose. Depends on the complexity of the feature that you're implementing. It's also sometimes you cannot fit the solution in less than 1,000 lines. It's impossible. So I wouldn't advocate for 400 lines rigid. See what works for your team first. Maybe 1,000 lines is good enough, and you have a good velocity, and you don't need to further reduce it. Or maybe yes. Another option you can look into, I would probably say spec-driven development. So instead of you write, it's kind of similar to RFCs and ADRs. So you write a spec first, you analyze the problem, you understand what and why before you actually start planning it. And once you plan, you can ask AI again to generate tasks, and each task could be an individual issue or subtask of your feature, and each task could be an individual piece of work that you can create a pull request and submit. Again, stacking in this case might work, but again, it very depends on how agile is the team in terms of the reviewing. So if it's dragging the review, so probably stacking doesn't work, but yeah, it's just a thought.
Can I get a huge round of applause? There's so many questions that Pavel just went through.